Uh, Nisha ma'am, welcome to the session. Good morning. So we will start with the session as we have everybody with us. So hello everyone, a very good morning to all of you, dear authors and invited guests. A very warm welcome to technical session 10A. Myself, Yashita, and I'll be your moderator for this session. I'll be making sure that everything runs smoothly and maybe try to keep up the energy too. So, on behalf of Global Knowledge Research Foundation and GR Scholastic LLP, it is my great pleasure to welcome you all to the 11th International Conference on Information and Communications Technology for Sustainable Development, which is ICT4SD 2026. The 11th edition of the conference is being organized in a hybrid mode, and the physical event is was held day before yesterday on 9th July, and the virtual event is being held through Zoom from 9th to 10th July, where people from all over India as well as many from other countries are present with us. So I hope that you all enjoy today's insightful and knowledgeable sessions. So, in this session, we will be having a total of 10 presentations, and each presenter will be given 10 minutes for presentation, followed by 2 minutes for question and answers. So, I will give a gentle reminder at the 9-minute mark just to help everyone stay on track. And it is a kind request to all the presenters that please try to stick to the time as we are time bounded and we have less hours to finish all the 10 presentations, so that we can discuss on the paper as well. So there's one more request that please stay connected with us till the closing remarks. We promise that the session will be worth it. And if you have any queries or updates to give, please feel free to drop them in the chat box anytime. Me and my co-host will be addressing them. So before we begin, I would like to introduce everybody to our session chair for today. We have with us Dr. Nisha Abhijit Auti. She is an associate professor in the Department of Computer Science and Engineering at Bharati Vidyapit, deemed to be University College of Engineering, Pune, with 14 years of experience. Her research interests include artificial intelligence, machine learning, data science, and cybersecurity, and she is actively engaged in teaching and research in these areas. So, welcome to the session, Nisha ma'am. Would you like to say something to start today's session?
Thank you very much, Yashita, and I hope it will be a great session for all of us. Thank you very much.
Okay, thank you so much, ma'am. So, we will begin with the presentations now. So, our first presenter for today, we have SS Niranjana. Are you present in the session, Niranjana?
Yes, ma'am.
Yes, so she is going to speak on the topic, a priority aware big data framework for industrial IoT using fuzzy logic and LLMs. So, yes, Niranjana, you can start sharing your screen.
Yes, ma'am. I'll just share the screen.
Okay. You are her co-author, right?
Yes, ma'am. The three
Okay.
of us will be presenting.
Okay.
Good morning, everyone. I'm Swati Kumar, and today I'll be presenting our work along with my teammates Svojis and Niranjana. Our work, titled A Priority Aware Big Data Framework for Industrial IoT Using Fuzzy Logic and LLMs, was conducted under the guidance of our professor and co author, Dr. Animesh Giri. Here's the roadmap for today's presentation. Here's the roadmap for today's presentation. Before diving into the technical details, let's understand the motivation behind this work. Modern industries rely heavily on IoT sensors that continuously generate enormous amounts of data. However, not all events are equally important. A critical machine failure should obviously be processed faster than routine monitoring data. This motivated us to develop a system that can intelligently prioritize events and process them according to their urgency. Most existing systems process all events using a single pipeline, which means critical faults may get delayed behind less important events. Such delays can lead to equipment failure, production downtime, and even safety hazards. Additionally, existing approaches often rely on fixed thresholds and lack of contextual reasoning capabilities. Therefore, there was a clear research gap that we were working on. Our research objective, the main objective, was to develop a framework which is capable of processing industrial IoT events according to their priority levels. Specifically, we aim to classify events into critical, warning, and normal categories using fuzzy logic. Route these events through optimized big data pipelines based on priority, and generate context aware fault explanations and recommendations. Our work also addresses two important research questions. First, how can industrial IoT events be prioritized efficiently? And secondly, can priority aware pipelines reduce latency while still maintaining scalability?
A proposed solution addresses this by building a priority-aware big data pipeline for industrial IoT. It begins with sensor data collection, followed by edge-level processing, and then a fuzzy logic engine that classifies every event as critical, warning, or normal. Based on this priority, the data is routed to a dedicated processing pipeline: Kafka and Flink for critical events, RabbitMQ and Spark for warnings, and Hadoop for normal data. And finally, an LLM adds contextual reasoning before results reach the dashboard. Here's the same flow visually. Industrial IoT data enters through a fuzzy logic engine, which runs 27 rules to decide the priority. Each priority branches into its own pipeline, and all three converge at the Phi3 LLM reasoning engine, which generates final insights shown on the analytics dashboard. Starting with data collection, the sensors continuously monitor vibration, temperature, and pressure. At the edge, we perform noise reduction, data cleaning, and feature extraction before this pre-processed data is handed off to the fuzzy logic classifier. This is the core decision layer. Each sensor reading is categorized as low, medium, or high, and a 27 rule Mamdani fuzzy inference system evaluates the combined sensor readings to determine the machine's condition. For example, low vibration with high pressure is flagged critical, while medium readings across the board trigger a warning. This lets us compare nuanced real world fault conditions rather than relying on rigid thresholds. Once classified, each priority level is handled by a purpose-built pipeline. Critical events go through Kafka and Flink for real-time processing with lowest latency. Warning events use RabbitMQ and Spark streaming for micro-batch processing, and normal events go through Hadoop MapReduce, optimized for high-throughput batch processing. This way, we are not wasting any real-time infrastructure on low-priority data. After processing, outputs from all the three inputs are aggregated and passed to a lightweight LLM, Phi3 Mini. It performs contextual reasoning, root cause analysis, and fault explanation, turning raw sensor anomalies into insights that support predictive maintenance, decision making, and operator recommendations. The system responds differently based on severity. Critical events trigger real-time alerts, warning events generate maintenance recommendations, and normal events are simply logged for historical trend analysis. As you can see on the right, the LLM just does not flag an issue. It explains the risk and recommends specific actions, like this temperature anomaly in zone 3. For the experiments, a synthetic industrial IoT fault detection dataset from Kaggle with a realistic event distribution of 50% normal events, 30% warning events, and 20% critical events was used. The pipeline was deployed locally using Kafka, Flink, RabbitMQ, Spark, Hadoop, a Python-based fuzzy logic engine, and Phi3 Mini through Olama runtime, enabling end-to-end evaluation of the system.
Talking about the performance metrics, so to assess the the priority-based pipeline, we focused on two main metrics. That is, first, initial latency. Latency is the difference between the system response time as well as the event occurrence time. Now, the system response time was obtained. It was obtained from the event log, and that is and the event response time was at which the event exits the processing pipeline. Next slide, please. Throughput measures the number of events handled at the given time interval. It is calculated as the ratio of the total events processed by the time window. And the time window selected here was 60 seconds. Next slide. The explanation correctness score ECS, this metric evaluates the explanation based on 6 criteria: sensor reference, threshold reasoning, risk explanation, action appropriateness, faithfulness, and completeness. So ECS is normalized based on these criteria, and this is required because the value is bounded between the 0 to 1 range and it is comparable across multiple events. Next slide. These are the six criteria that were mentioned before. Now, results and analysis under latency, we have the critical priority pipeline that recorded an average latency of 101.75 milliseconds due to PyFlink, JVM Python bridge, Kafka broker ingestion, and as well as the Flink's internal processing. So, warning priority pipeline recorded an average latency of 1191 milliseconds, which reflects Spark back micro batch execution with the queuing overhead of RabbitMQ. The normal priority pipeline exhibited an average latency of 14,634 milliseconds, reflecting the cost of the HDFS block allocation, map reduced initialization, and disk-based shuffle operations. Throughput, next slide. Here in the throughput, in the last graph, we can see the critical priority pipeline recorded an average throughput of 8,516 events per second, benefiting from the Kafka's partitioned architecture and the Flink's pipeline execution. Warning pipeline achieved a moderately lower throughput of 6,387 events per second due to RabbitMQ's single queue design and Spark micro batch scheduling overhead. The normal priority pipeline recorded the highest average throughput of 26,300 events per second, and this is due to Hadoop's ability to process large volumes of data in parallel. Next slide. So the key findings on the ECS was that our results show that warning events achieved the highest ECS score of 0.813, indicating that the LLM generated accurate and well-grounded explanations. Normal events recorded an ECS of 0.786, while critical events achieved 0.711. Although the critical events was lower, this is expected because they involve more complex scenarios and require more precise action recommendations. Next slide. So discussion, the priority-aware architecture successfully routes to the most important events based on their level of urgency, and this allows the critical events to be processed with minimal latency, while the routine events were handled efficiently by the batch processing methods. Secondly, the fuzzy logic classifier effectively manages in the sensor readings, enabling accurate event prioritization. Finally, integrating the LLM adds an explainability layer by providing contextual description and recommended actions, making the system more useful for the operators.
To conclude, we implemented the priority-based event routing and evaluated the framework using latency, throughput, and explanation correctness score. The results demonstrate that our approach enables faster responses to critical industrial events, improves the resource utilization and scalability, and supports intelligent, explainable decision-making in industrial IoT environments. Overall, this research demonstrates the potential of combining big data technologies and AI techniques to build more efficient and reliable industrial IoT systems. These are our references. Thank you for your attention. We would be happy to answer any questions.
Yes, Nisha ma'am, you have any questions for them?
What are the evaluation parameters of your system?
Ma'am, these are the evaluation parameters. So we had latency, throughput, and for the LLM, we also had the ECS score, which is the evaluation correctness score.
So what are the findings of all these evaluation parameters?
Ma'am, we noticed that the latency was most minimal in the the critical pipeline, and then we had that warning pipeline with like 1,191 milliseconds. Finally, we had the normal pipeline because it was using Hadoop. We had 14,634 milliseconds. And similarly for throughput, next slide. Throughput normal pipeline achieved the highest of 26,300 events per second because it processes due to its parallel processing in batch.
Okay.
Okay, thank you so much, Niranjana, for your presentation.
Thank you, ma'am.
Yes. So next we have Ravin Kumar to present his paper titled as Adaptive Base Representation Theorem, Mathematical Foundations. So Ravin, are you present in the meeting?
Yes, ma'am.
Yes, so you can start sharing your screen.
Okay, is my paper this visible?
Yes, it is visible.
Just 1 second. Okay. So, hi everyone. Myself Arvind Kumar, and I'm presenting the paper Adaptive Base Representation Theorem, Mathematical Foundation. So, this is my follow-up paper on this work, basically more towards the mathematical grounding and foundations of this work. So this paper asks a very fundamental question. So like digital computers, all of them works on binary number system, which is like if you at the bottom you can see the mathematical formulation of binary number system. So we asked a very simple question that can we have a number system which have a same storage capacity as binary number system? In simple terms, which it means, given let's say n number of bits, can we have a number system which can store all the numbers that binary can store for those n number of bits without any replication or missing any number? For example, for 2 bits, binary can represent 0, 1, 2, 3. So can our number system represent 0, 1, 2, 3 for 2 bits? Just an example. So the foundational work was published last year in Springer itself. There we talked about its application in computer science, that is steganography, data compression, and error detection and correction mechanism. This paper particularly focuses more on the mathematical proof. One may ask why. The reason is in the previous paper, the proof was made by proof by construction, which in simple terms means I test part A, I test the part B, I test the combination of these, and then I say, hey, this entire thing is working, thus the system works. But in mathematics, we require a deeper proof to say something is working. So this paper is the part of that work. Yeah. So this is our ABR number system. Just 1 second, let me increase the screen. Yeah. So let's say SA is a bit sequence, that is bits like zero at index 0, 1, 2, 3, blah, blah, and -1 for a number of bits. So in binary, we have base in the power of 2, that is 2 to the power 0, 2 to the power 1. In binary number, in ABR number system, our base is defined in this format with some conditions applied on the index high. So our another focus on this paper was, can we get so I'll just mention the next slide. Yeah. And the value that is represented in ABR number system, that is the decimal value, is represented with this formula, that is -1 to the power epsilon I. Di means the binary value, that is 0 or 1. And bi means the base value, which in binary is like 2 to the power 0, 2 to the power 1. We have a different formula for this, that is this particular base equation we use. And epsilon I is defined in this particular format. So one important thing to notice here is when I is odd, epsilon I is 0, that is this thing becomes 1. So think of it like when I is even, we overshoot. We sort of like it becomes negative. We sort of like kill the overshoot value so that the entire numerical value falls in the range of binary. And so this is the theorem. So in simple terms, let Bn be the set of number representable in n bits in binary number system, and An is a set that represent n numbers in n bits in your adaptive based representation number system. Those two sets are equal for all n greater than equal to 1. So basically, we are saying the range of these two number systems, or the representable values for every single bit length, is exactly same. So here is a very simplistic mathematical proof. We represent Bn as a set of, you can say, binary number system, An as set of adaptive based representation number system. So this was our theorem, and this is our number system, An. And we made a proof as in like basically we defined what is B0, that is the base value at index 0 at index 1, calculated using our formula, which we have here, Bi. Yeah. And after that, what we did was we calculated these values for when number of bits or bit length is equal to 1, we get value either 0 or 1 in binary. Similarly, in ABR number system, we get 0 and 1. Thus, for when n equal to 1, both the number system are same. Similarly, for n equal to 2, we get both the number system as same. As you can see in the bottom right, it is 0, 1, 2, 3, which is same for ABR and binary number system. Now, what we have done is we have created a closed form. Closed form, one may ask why. If you can see, Just 1 second. Yeah. So if you can see here, this bi is like dependent on the previous values of I. So it's like an iterative process. Think of it like if I want to calculate the base value at index 11, I have to calculate every value from 0 to 10. So which was not efficient. So we proposed a lemma that for every m greater than or equal to 1, b2m is equal to 2 to the power 2m, and b 2m plus 1 is equal to 3 times 2 to the power 2m. So basically, in very simple terms, what we are saying is when the bases are even, it will have exactly same base value that of your binary number system. But when the bases are odd, that is plus 1 means like odd, it will be 3 into 2 to the power 2 1. That is the, for example, if we are calculating for 7, that is 2 into 3 plus 1, this will become 3 into 2 to the power 2 into 3, instead of being 2 to the power 2 into 4. Okay. So what we did was, for this lemma, we first proved for the 2m value, and then we have further used it to prove for 2m plus 1. So here, if you can see, for m is equal to 1, we proved it that, hey, basically b2 is equal to 2 to the power 3 minus 1 in the summation. And similarly, we calculated b2, which is 2 to the power 2. Then further, we calculated b3, which is like odd number, which will be 3 into 2 to the power 2. Basically, it's like 2 plus 1. So like 2 is here. And with the inductive hypothesis, we further proved for this value be 2m plus 2, that is for the even value. And basically, this is the like formal proof if you want to go in this. And then for the odd index values, we further use the same logic to prove. So in this particular slide, we prove this lemma that for the even indexes, the base will be same as that of the binary, and for the odd indexes, our ABN number system have a different base, which we can get directly from this. No need to do the like this summation logic which we have put here. Basically, we made it efficient. Earlier, it was a iterative step. And after using these base values, what we did was, yeah, what we did was we first used this lemma to prove that for even number of bits, our ABR number systems theorem hold, and then we proved the same thing for odd number of bits. Yeah. So basically, for r equal to, so n is equal to 2r, basically even number can be represented in this form, 2r. When r is equal to 1, this was exactly our case 2, that is a2 equal to b2 equal to 0, 1, 2, 3. When r greater than or equal to 2, we just have to prove like a 2r plus 2 is equal to b 2r plus 2. That is in mathematical form, this number. So the highest 2 bits will always be in this format. One may ask why it is like 2r plus 1, because our index is starting from 0. So even bit length will have the highest bit with the odd index. So that's why. So basically, then what we did was we calculated the combination of these two values, which is like either 0, 0, 0, 1, 1, 0, 1, 1, which using our lemma.
Sir,
Sorry.
sorry to interrupt, but
Yes.
you will have to wrap up in next 1 minute because
Yeah,
it's
yeah,
like
we will, we
very
will. It's
late.
like it's about to
Yes.
complete. Yeah. So with this lemma, we proved it for even bits. Similarly, we took a union for these combinations. For even, it is proved. Similarly, for odd bits, it was very straightforward, as epsilon was having a definite value. So it was either 0 or 2 to the power 2r. So with the summation, we proved for odd number of bits also, that is 2r, a 2r plus 1 is equal to b 2r plus 2. Hence, the theorem is proved. Now, talking about every integer will have a unique representation. This is basically the second last slide of this presentation. So we created a map. With the map, what we said was, since from our theorem, an is equal to bn, and the numbers that can be represented in an is equal to the number that can be represented in bn is equal to 2 to the power n, which is the maximum capacity which bits can
Your
hold.
voice is not audible, sir.
Okay. So what we basically did was we calculate using our theorem. We said an is equal to bn, and the maximum numbers representable with with them is 2 to the power n, which is the maximum capacity of the bits. Thus, every number have a unique representation, which is like a corollary to our proof. So with this, the paper concludes. Here is like 2 slides for visual understanding of it. So these the first column is the bit index. For the binary number system, these are the bases. If you can see 1, 2, 4, 8, 16, 32, 64, blah, blah. For the ABR number system, it is like 2, 3, 4, 12, 16, 48. One thing to notice here is at every even index, okay, from starting from greater than 0, the values are same: 4, 4, 16, 16, 32, 64, 64. At odd indexes, we have higher values. Like it was in binary number system, it is 8. In ours, it is 12. Similarly, in at the bit index 7, it was 128. Ours is 192. But our formula with the usage of epsilon is able to get the same value result. So here is the basically representation of same numbers, number as in like from 0 to 15, the representation in binary number system and in ABR number system. So every number have a unique representation in our adaptive based representation number system. So thus what we can say is the theorem is proved, so it can be used for data storage and transmission. It has representational equivalence in terms of numbers that can be represented with n bits in binary and ABR. It can be used in steganography and compatible with, and that's this third and fourth, that is compatible with data correction mechanism and data compression mechanisms, was already published in the previous work. So these are the references. The point 7 and 8 is the reference to the previous published paperwork, which was the foundational work of this paper. Thank you.
Anybody, any questions? Nisha ma'am, do you have something? Okay, I think there are no questions. So, sir, you can stop sharing your screen. I will move forward with the next
Okay.
presentation.
Yeah. Thank you.
Yes. Thank you. You
What
wanted
are
to
the
say something,
computational
Nisha?
overhead and the requirement of your algorithm?
Sorry, can you please repeat, ma'am?
Ma'am, can you please repeat the question for him?
What are the computational requirement of this algorithm, and have you done the estimation of the cost of implementation?
So, ma'am, from the implementation point of view, so our focus for this particular paper was the mathematical proof of the first paper. And in the first paper, it was more about that apart from binary number system, no other number system exists which have the same storage capacity. People have tried multiple things, but they failed. Either the numbers were repetitive in nature. For example, instead of 0, 1, 2, 3, it was producing 0, 2, 2, something like that, or 0, 2, 5, that is out of bound for the range. So our most focus was not from the hardware or chip level implementation, but to take into account what we had done is we removed that summation logic with the closed form. So from the implementation point of wise, one point I want to add is uh, the shifting from, let's say, 6 to 7 in so basically in our binary number system, in 4 bits, how we represent 7 is like 0 1 1 1, that is 7, and 8 is 1 0 0 0. So in decimal number system, we although moved from one number, that is 7 to 8, but what we have done in binary is we have flipped all the 4 bits. That's what happened in binary number system currently. In our ABR number system, that flip is upper bound of n by 2. So the overall energy requirement by the system to even go from 1 to 100 in these scenarios will be constrained and less in ABR number system. Basically, because even with increase in one value, that is 7 to 8, in binary number system, we are flipping all the 4 bits. So even in things like machine learning, which relies heavily on embedding spaces for models to learn, it sort of like disturbs their embedding space. So, but from the point of view of like complexity wise, we haven't done that part because our most focus was on mathematical side of it. Because first it has to exist, like then we can implement. I hope I was able to answer it. Yeah.
Okay, Nisha ma'am, should we move forward with the next presentation?
Go ahead with the next presentation, and then all participants are requested to give presentation just within 10 minutes. Do not
Yes.
extend it more.
Okay, so next speaker is Prashant Vats. Sir, are you present in the session? Or any of his co-authors is present with us? Okay, let me check once. Okay, I think Prashant is absent. So next one we have Aryan Pahuja. Aryan, are you ready?
Yes, I'm ready.
Yes. Okay, so he is here with us to present his paper titled as Blockchain-Driven Transparency and Security in Interactive Systems, Implications and Case Study in Music Platforms. So Aryan, you can start.
Yeah, just a second. I hope my presentation is visible.
Yes, you can start.
Yeah, okay. Good morning, everyone. I'm Aryan Pahuja, and today I'm here to present my research titled Blockchain-Driven Transparency and Security in Interactive Systems. Let me start with the objectives of the research. So we will be studying how blockchain improves security and transparency in interactive systems. We'll also be comparing the centralized and blockchain-based architectures. We'll be designing a secured interactive music platform and integrate it with AI-based recommendations along with the blockchain technology. At last, we will be evaluating system performance and feasibility. So, most modern applications such as music streaming, online banking, and voting systems rely on centralized servers. This creates challenges such as limited transparency, security risks, and dependence on a single authority. Blockchain provides a decentralized approach where records are secure, transparent, and difficult to modify. Now, you would be curious, what is blockchain? Blockchain is nothing but basically a digital ledger that stores transaction in a series of connected blocks. Each block contains transaction data, a timestamp, and a unique cryptographic hash. Once a block is added to the chain, its contents cannot be changed without network consensus. This makes blockchain secure, transparent, and tamper resistant. So, blockchain is basically a digital notebook which is shared by everyone in the network and is very transparent. Now, I will be explaining the implementation architecture of the blockchain, but before that, you must be familiar with a few terms. The first one is transaction. Transaction is basically an action that is performed by a user, such as casting a vote, sending money to someone, etc. We have block, which is a container that stores verified transaction along with a timestamp and a unique hash. Hash, which is a unique digital fingerprint that securely links one block to the previous block. Nodes, which is basically the computers in the network that store a copy of blockchain and verify all the transactions. And we have consensus mechanism, which is basically a process that is used by nodes to agree on a particular transaction. I will be explaining the architecture with an example. So, like if some person wants to send money to another person, so we can start when a transaction is initiated. So, the data of the transaction, such as the sender's account, receiver's account, balance, amount, all the details are written as a transaction and is stored in a block. That particular block is sent to the members of the blockchain who are called market makers or miners who consensusly approve the transaction, and that then when the block is approved by the network, this is added to the blockchain, which basically create a chain of block where each block contains the data of the transactions, the timestamp of the block, and a cryptographic hash that links it to the previous block. So once the block is added to the blockchain, the update is distributed to all the network, and the next block is mined with the previous block's hash. So this is how the architecture of blockchain is formed. Now, we will be comparing the traditional systems versus blockchain-based systems, how they differ. So, traditional systems are centralized architectures that are controlled by a single authority, whereas blockchain is a decentralized network with multiple participating nodes. In a traditional system, user must trust the central organization for authenticity, whereas in blockchain, trust is established through consensus among network participants. In traditional, data can be modified or deleted by administrator, whereas in decentralized system, data is immutable once recorded on the blockchain. In centralized systems, single point of failure is there if the server is compromised, whereas in blockchain, there is no single point of failure since the storage is distributed among the members. In the traditional system, there is higher risk of data tampering since the centralized system can manage all the data. Whereas in blockchain, the data is cryptographically secured on the chain and it prevents unauthorized modifications. Now, this is the interactive experimental setup that I built for understanding how blockchain can be implemented in production-based architectures. So I created a music platform where basically there can be multiple rooms where users can join the rooms and vote for songs they want to play. So basically, each song is stored as a vote in the blockchain. So when a user votes for songs, then each vote is stored in the blockchain, and Kafka handles real-time events of that all the vote changes. And then AI also recommends songs with the blockchain to create a complete architecture of a production-grade system. What we achieved as results from this was that we were able to achieve a 500 TPS of throughput, which basically is sufficient for room level interactions. We got tamper resistance since blockchain is 100% immutable and shared by everyone, so it prevents vote manipulation. The confirmation time of one transaction is 2.4 seconds, which is slightly higher than traditional systems, but it can be implemented since if we want more transparency and security in a particular system. For auditability, every vote is recorded on the blockchain as a transaction in a block, which makes the voting process transparent and traceable. So overall, it was an improved security, fairness, and transparency with only a small increase in the transaction latency. So we will also be now understanding what can be the limitations of using this. So first of all, higher storage. Since the node is distributed among all the members of the network, so each member has a copy of the node of the blockchain, which creates a high amount of storage requirement. The transaction is a little slower than the traditional system since consensus verification takes time. It can be higher at cost because deployment and maintenance require additional resources other than the traditional resources. We are able to integrate blockchain with the existing systems also can be challenging because they are built on a traditional based architectures. And it is also not suitable for every application since traditional databases are better for applications that do not require decentralization or transparency. Coming to the conclusion, blockchain significantly improves trust, transparency, and security in interactive systems. This proposed architecture ensures fair and verifiable voting. Combining blockchain with AI recommendations enhance the overall user experience, and this approach can also be applied to domains such as healthcare, e-governance, and supply chain management. These are a few references that I used to study this research. Thank you. I'm happy to answer any questions.
Okay, Nisha ma'am, any questions for him?
No, ma'am. The next presentation.
Okay. So for our next presentation, we have Sarang Chandra. Sarang, are you present in the session?
Yes.
Yes. So he is going to speak on his paper titled as Consumer Perceptions of Fast Fashion, Evidence from Online Customer Discussions and Gen Z Focus Groups. So Sarang, you can start.
Okay, thank you. Is my screen visible?
Yes, sir, it is visible.
Good morning, all. So I'm gonna do my presentation on consumer perceptions of fast fashion. And our teammates consist of Saru, Chitra, and myself, Sarang. And so coming to the introduction. So we all know fast fashion offers affordable and trend-driven clothing with rapid production cycle. So brands like Zara, H&M, Shein have transformed consumer buying behavior with the fast fashion. So despite its popularity, fast fashion raises concerns regarding environmental pollution, textile waste, ethical labor, and more. So as Generation Z is aware of sustainability issues but continues purchasing fast fashion nowadays. So understanding consumer perception is important for promoting sustainable fashion practice in future and coming days. So the objective here is to access consumer perception of fast fashion and to analyze consumer discussions on Reddit using sentiment analysis and topic modeling, and to explore Gen Z perceptions of fast fashion through focus group discussions to understand the factors influencing fast fashion consumption among Generation Z. And so the community methodology. So we have used a mixed method research that consists of secondary and primary data. So coming to secondary data, we have used Reddit as a platform to get the discussions on fast fashion. And we have done a keyword-based web scraping in that. And primary data we've done a focus group discussion consisting of 6 Gen Z participants. And the way what we have done with Reddit data is that we have used better sentiment analysis that classifies it into positive and negative. And come to the word topic modeling identifier that gives each theme for it. And that consists of affordability, trendiness, consumer behavior, sustainable disposability. And the focus group data, we have used a thematic analysis that gives us codes and themes according to it. And coming to results and discussions. So these are the sentiment analysis. We have seen as the positive is more, neutral is second, and negative is the third one. And key findings from this that majority of Reddit comments shows positive sentiment, and neutral sentiment is the second highest, and negative is a smaller one. So what we understand from this is that positive indicates that consumers generally perceive fast fashion favorably because of its of neutral negative sentiment shows that. Am I audible? The presence
Yes,
of
sir,
neutral
you're
negative sentiment.
audible.
The presence of neutral and negative sentiment shows that consumers also recognize concerns regarding environmental impact, product quality, and overconsumption. So overall, the consumer perception reflects a balance between the functional benefits of fast fashion and growing sustainability concerns. And we have used topic modeling. So see that this is the graph of topic modeling. And from this, we can see a major theme identified that we got our affordability, trendiness, convenience, consumer behavior, sustainability concerns, and disposable nature of fast fashion. These are discussions that consumers are primarily attracted to fast fashion because it is fashionable, affordable, and convenient. And sustainability topics appear frequently, indicate that consumers are aware of environment issues. However, discussions suggest that style and affordability continue to outweigh sustainability concerns during purchase decisions. This demonstrates that consumer perception is shaped by competing motivations rather than sustainability alone. And next is the focus group discussions we have done to 6 Gen Z participants. And you can see the transcript, and we have done an Excel code from that. And we have get a selected theme. And so theme one was fast fashion consumption behavior. That is trend responsiveness, occasion-based purchasing, self-expression through fashion. And theme two does out drivers of fast fashion adoption. That is affordability, social media influence, and fear of missing out. And theme three is environmental ethical concerns, that is pollution, textile waste, and unethical labor practices. And theme four was barriers to sustainable fashion adoption, that is high cost, limited availability, and lack of variety. So what we understood from that was Gen Z views clothing as a medium for identity and self-expression, making fashion choices highly trend-driven. Affordability remains the strongest purchase driver. Social media platforms influence significantly encourage frequent purchases and reinforce fast fashion consumption. So this is why Gen Z continues purchasing fast fashion despite being aware of sustainability issues. And participants demonstrate awareness of the environmental ethical consequences of fast fashion. However, this awareness rarely translated into sustainable purchasing behavior, indicating attitude behavior gap. So, such sustainable fashion is often perceived as expensive, less accessible, and offering fewer choices, making fast fashion the preferred option. So, improving affordability and accessibility of sustainable products could encourage greater adoption among consumers. So contribution we have done is that demonstrate the coexistence of positive perceptions and sustainability concerns, showing affordability, trendiness, and convenience continue to outweigh environmental ethical consideration, consumer decision making. So then provides valuable insights into Gen Z consumer behavior, that is identifying key factors influencing fast fashion adoption, including affordability, social media influence, self-expression, and FOMO. So it identifies major barriers to sustainable fashion adoption, including high perceived cost, limited product availability, and lack of variety, offering practical guidance for improving sustainable fashion accessibility, and offers strategic implications for fashion brands, marketers, and policymakers by emphasizing the need to balance affordability, accessibility, style, and sustainability to encourage responsible consumer choices. And what we face the limitations are we have used Reddit as the primary online data source, which may not represent the opinions of all consumer groups. And the focus for discussion include only 6 Gen Z participants, that is limiting the generalizability of the findings. So the study is cross-sectional, capturing consumer perception at one point in time, while perception may change with evolving fashion trends and sustainable events in the future. And future research can include multiple social media platforms and a larger, more diverse sample to gain broader insights into consumer perception. And longitudinal brand specific cross cultural studies can further explore how consumer perception of fast fashion change over time and across different markets. So thank you.
Okay, Nisha ma'am, any questions? Okay, I think so. There are no questions.
Okay.
Forward with the next presentation. So next we have Kumaran Kala Narayan Swami. So sir, are you present in the meeting?
Yes, ma'am, I am here.
Yes. So he's here to present his work titled as From Projects to Product Mindset, Redefine. Start. You can start with your presentation, sir.
Yes, ma'am, I'm just sharing my screen. Let me know you're able to see my screen.
Yes, sir, it is visible.
It's visible, right, properly?
Yes, sir.
Okay. Good morning, everyone. I'm Kumaran, presenting joint work with Dr. Shubham Singh of Symbiosis. Our paper, From Project to Product Mindset, primarily asks one question, right? Why do IT services firm keep investing heavily on agile, AI, and DevOps, but they still fail to deliver sustainable digital transformation? So in this paper, we argue it's not a new technology as such, but what is the missing link, right? While it is not new technology, it's a mindset shift from project to product. So let me show what does that mean. Primarily, most of this IT services company still operate uh, for the contract with a fixed scope, pretty much trying to meet the SLA timeline and milestone, where the expectation from customer is how do these IT players can continuously drive value through continuous innovations and ownership, and also deliver business outcomes. So this shows up in 3 ways, right? Today in IT services, work on an episodic delivery, trying to complete project project ends at an handover, right? There's no continuity of ownership. There's no continuity of improvements to the entire project what has been delivered. And also they work on a wrong metrics, trying to ensure that SLAs and milestones are achieved, but forget to deliver the business outcomes and the value for the end customers. In the process, innovation gets blocked because the focus is on more on the fixed scope and SLA, trying to avoid penalties. But in the process, some of the investment made on AI and Gen AI becomes more adoption, not trying to create a co-creation the value. In the process, the investment in these capabilities uh, give the discrete output, not a strategic digital transformation, right? So what we want to bring in a product mindset. So just want to let me define what is product mindset, right? So product mindset is an organization approach and logic that delivers continuous value for the customer through outcome oriented governance, which provides continuous evaluation of digital solutions throughout the life cycles by co-creating value for customer rather than just working for contracts or a project delivery, right? So it breaks into four dimensions. Continuous value delivery, we talked about it. This is where the digital project becomes a living assets throughout the life cycle rather than just giving one delivery at a time. And also do a end-to-end ownership. Start the accountability start from concept to operations and provide continuous improvements. Then how do we bring in a customer-centric decision making through empowered with the data and AI insights rather than just working on SLA and project milestone counts. Fourth dimension is creating cross-functional value stream, right? Starting from developer, QA, security, business analyst, and aligned as a persistent team which drives value and gives the outcome driven results. So this is not at the philosophy. This is grounded in established theories that's formed into our theoretical foundation. So this framework draws on four key established theories: product service systems, which works on a long-term product performance and the service over across life cycle; the service dominant logic, which focus on co-creating continuous value, working with customers; a lean and agile, which improves your time to market, faster feedback cycle with customers, close interactions; and a dynamic capability where organization understands sense the importance of changing needs of business transformation for client expectation, right? So in the together, these four give something important for us, right? That is product mindset, which becomes strategic capability, not a mere delivery practice which traditionally being used in the IT services. So how do this IT firm make actual shift, right? We model this a transition model. On the left, you see the project-based IT drive the limited value for the customers and lesser ownership. While trying, when we adopt the product mindset, deliberate action, it translates into a product oriented, which drives the higher customer value, highly satisfied customer. This transition is anchored by four key actions, right? Aligning our IT objectives to business goals, right? Second one is how do we ensure that deliver sustainable long-term value, not just one time you deliver projects and stop it, right? Because customer needs are evolving in the current digital transformation. So with that, continuously drive your improvement in the process, enabling our customers to grow their business as well. So this model
Sir,
improves.
you will have to conclude in next 2 minutes as it's
Yes,
already
ma'am.
time.
Yeah.
Yes.
So the core aspect of this paper is about the innovation, which is where the conceptual, the framework is first of my kind to our thought process in the IT services for product mindset, and the foundation how the IT services are understood. KPI framework shift from activity to outcome-based metrics. It's a ready-to-use six dimension framework, and product mindset acts as a strategically the product mindset acts as a unifier wherein these capabilities are driven into a dynamic competitive advantage capabilities. So coming back to this is where the major shift makes, right? So what gets measured changes what gets managed. I'll take few examples. Usually the center, the value dimension, how the project-based SLAs like milestone completion and scope adherence translate into high customer value creation, business outcome realization, right? Same way like on-time delivery, schedule variance translate into faster deployment, lead time reduction changes. So how does this contribute to sustainable impact, right? So you see long-term ownership drives the stable and skilled digital roles than the contracts. The product means drives continuous innovation, wherein the agile DevOps AI translates into a strategic partnership on SDG 9, while 12, where it contributes from reduced effort from wastages like cycle time reduction, redundant projects. Not but the least, the 17 basically transforms from a traditional transactional relationship from client partner relationship to digital and strategy. So let me leave you with the four key takeaways. Project delivery optimize project completion, while the product mindset actually drives continuous innovation and delivers the business outcomes. Product mindset is not another practice. It is actually integrates or unifies the agile and AI and DevOps into competitive advantage. So in summary, sustainable development needs responsible long-term ownership. Let project delivery, product mindset is a pathway which actually drives sustainable digital transformation and business value to the end customers. Thank you. I'm happy to take your questions.
Yes, Nisha ma'am, any questions?
What are the practical applications of this system, and what are your deployment plan?
So these is at this point in time, it's conceptual and theoretical. The future objective is to do a empirical validation, ma'am, on the IT services companies where these framework can be deployed.
Okay, thank you.
Okay,
Thank
thank
you,
you so much,
everyone.
sir, for your presentation. I once again kindly request all the participants to please complete their presentation within 9 minutes because the time is running and we need to finish all the presentations within the given time. So next we have Atul Kumar. Atul, sir, are you present? Or any of his co-authors is present with us?
Yeah, good morning. This is Dr. Ashutosh Bajpayee, and I will be presenting on behalf of Dr. Atul.
Okay, so he's here to present his paper titled as Integrated Decision Support System for Sustainable Organic Agriculture. So, sir, you can
Yes.
start with the presentation.
Uh,
And please take care of the time.
sure, ma'am, sure.
Yeah.
Am I able to share my screen, ma'am? Is it visible?
Yes, it
My
is
screen?
visible. Yes.
Okay. Just a minute. Give me a minute, ma'am. Few seconds only. Good morning, everybody. This is Dr. Ashutosh Bajpayee, and presenting this paper. To present our paper titled Integrated Decision Support System for Sustainable Organic Agriculture. And this work proposes Kishan Mitra, that is an artificial intelligence-based integrated decision support system that assists organic farmers by combining crop diseases detection, crop recommendation, and market price forecasting into a single intelligent platform. And as far as background is concerned, organic farming is environmentally sustainable, but farmers face several challenges, including this outbreak, fluctuating market prices, and uncertainty in selecting suitable crop. Although AI has been successfully applied in agriculture, existing solutions focus on isolated problems. Our motivation was to integrate multiple AI models into one comprehensive platform capable of supporting farmers throughout the cultivation cycle. The primary research objective was to design an intelligent platform that combines multiple AI technologies for supporting farmer decision making. And the process system not only predicts diseases but also recommends suitable crops and forecasts future market prices to maximize farmers' income. That is the main motive of farmers. Now, proposed system architecture The architecture consists of four interconnected layers. The farmer interacts through a mobile application. The collected data are processed and forwarded to three AI models. The outputs are then integrated into a rule-based advisory engine that provides personalized recommendation. Now, the methodology, three artificial intelligence algorithms were employed. First one, a convolutional neural network detects diseases from crop leaf images. Second, a random forecast classifier recommends the most suitable crop using soil nutrition, rainfall, temperature, and pH. And the third one, a dual LSTM predicts future market prices based on historical commodity prices. The outputs of these models are integrated to generate practical recommendations. Now, as far as experimental results are concerned, the proposed model significantly outperformed baseline hypothesis. The CNN achieved nearly 97% classification accuracy. The random forecast accurately recommends crop with over 94% accuracy. The LSTM generated highly accurate market forecast. Statistical tests confirm that these improvements are significant. Now, sustainability impact beyond predictive performance, we evaluated the sustainability impact through simulation. The system reduced fertilizer using by approximately 22%, and the crop yield that increased by approximately 13.6%. And most importantly, farmer profit improved by over 26%. That is amazing. These findings demonstrate that AI can simultaneously improve productivity and environmental sustainability. Uh, Now, in conclusion, Kisan Mitra integrates multiple artificial intelligence models into a single platform for organic agriculture. And the proposed system delivers accurate diseases detection, crop recommendation, and price prediction while improving sustainability. Future work will focus on integrating IoT sensors, explainable AI, and large scale deployment across different agro climate regions. Now, this is all about my presentation as far as the paper is concerned. If there are any questions, so I will be happy to answer those.
What are the key parameters does your decision support system consider? Am I audible?
Yes, ma'am,
Yes,
you're
yes,
audible.
yes, yes, ma'am. What is the? Can you repeat, ma'am?
What are the key parameters of that your system has considered?
We have worked on intelligent platform that combines multiple AI technologies and how the overall profit can be increased and what we can do while choosing the right crop for the farmers and how this fertilizers uses can be increased, can be reduced, and the crop yield can be increased. All these things.
How your system has improved the sustainability in organic farming?
Yes, ma'am, exactly what I have concluded that whatever AI system we have introduced that has given a sustainable impact, increasing crop yield and reducing the fertilizer user, and most importantly, the farmer profit that was improved to approximately 26%. That is the sustainable impact of our research.
Thank you.
Okay, thank you, and thank you.
Okay, thank you so much, Kumaran sir, for your Ashutosh sir, for your presentation.
Thank you, madam, for
Uh,
giving the opportunity.
yes. So our next speaker is Sharath Chandra Patil. Are you present in the session?
Yes, ma'am.
Yes. So he is here to present his paper titled as Secure and Efficient Digital Evidence Management Using Blockchain and IPFS. So you can start presenting your screen.
Is my screen visible?
One second, please. Yes, it is visible. You can start.
Yeah. Good morning, everyone. I'm Sharath Chandra Patil from BMS Institute of Technology and Management. Today I'm presenting a work titled Secure and Efficient Digital Evidence Management using Blockchain and IPFS. Digital evidence plays a critical role in cybercrime investigations and legal proceedings. Our work proposes BlockSecure, a framework that combines blockchain, IPFS, and machine learning to provide secure, intelligent, and tamper-resistant evidence management. With the rapid growth of cybercrime surveillance systems, cloud services, and digital communications, the amount of digital evidence generated during investigations has increased tremendously. However, existing evidence management systems have several limitations. Most rely on centralized repositories, making them vulnerable to tampering, unauthorized access, and single point failures. The chain of custody is often maintained manually, reducing transparency and increasing the possibility of human error. As evidence volume grows, storage, scalability, and retrieval also becomes major challenges. These issues motivated us to design BlockSecure, a decentralized framework that ensures secure evidence preservation. Coming to the proposed framework, our literature review showed the current solutions address only individual aspects of evidence management. Blockchain-based systems mainly provides immutable logging, but do not perform intelligent evidence analysis. IPFS improves decentralized storage, but retrieval latency and fragmented data reconstruction remains concern. Machine learning techniques are used for document classification, but they are rarely integrated with blockchain-enabled evidence management. To address this gap, we developed BlockSecure, which combines blockchain, IPFS, and ML techniques and automated integrity verification into one unified and scalable architecture. Our major contribution includes a hybrid blockchain IPFS architecture, AI-assisted document intelligence, multi-level evidence verification, and continuous evidence monitoring. BlockSecure follows a three-tier architecture. The presentation layer provides investigators with an interface for case management, evidence upload, retrieval, and document analysis. QR-based physical evidence for tracking. The application layer handles authentication, evidence processing, blockchain communication, machine learning services, and integrity verification. Finally, the persistence layer consists of three components. IPFS stores the digital evidence in a decentralized manner. Hyperledger Fabric stores immutable evidence provenance records. MongoDB stores metadata, case information, and audit logs. This layered architecture makes the system secure, modular, and scalable. The workflow consists of three phases. In the first phase, investigators upload digital evidence. The system generates a SHA-256 cryptographic hash, checks for duplicate files, uploads unique evidence to IPFS, generates a content identifier or CID, and records the hash on Hyperledger Fabric. In the second phase, the evidence is linked to an investigation case, while metadata and audit logs are stored in MongoDB. During retrieval, the investigator is authenticated, the evidence is fetched from IPFS using its CID, and the SHA-256 hash is recalculated. The newly generated hash is compared with the blockchain record before the file is downloaded. If any mismatch is detected, the system identifies it as evidence tampering and blocks access. This ensures every evidence transaction remains cryptographically verifiable. Besides secure storage, BlockSecure also performs intelligent forensic document analysis. The pipeline begins with OCR, which extracts text from scanned documents. The extracted text is cleaned and normalized. Next, TF-IDF converts the text into numerical feature vectors. These features are compressed using singular value decomposition, which is SVD, reducing dimensionality while preserving important information. Finally, FFNN, which is Forward Neural Network, classifies the documents. The system also performs semantic search, duplicate detection, metadata generation, and intelligent document indexing. This significantly reduces manual effort while improving retrieval efficiency and forensic analysis. To evaluate a framework, we tested BlockSecure using forensic datasets of 100, 200, and 500 MB. Compared it with conventional IPFS. Unlike standard IPFS, which creates many small chunks, BlockSecure uses structured 1 MB chunk allocation. As we can see in the first graph, standard IPFS takes 256 as its regular chunk size, but ours is variable. So based on the file size and its priority, the chunk file size is decided. This reduces chunk fragmentation. This reduces the chunk fragmentation by nearly 75%. As a result, retrieval performance improved by approximately 15 to 18% for larger evidence files. Storage consistency also improved because of predictable chunk sizes, while blockchain anchoring ensured evidence integrity throughout the evidence lifecycle. Overall, the results demonstrate that BlockSecure achieves better retrieval efficiency without compromising security, transparency, or decentralization. The main contributions of our work are fourfold. First, we developed the unified evidence management framework integrating blockchain, IPFS, and ML techniques. Second, we introduced multi-level integrity and verification using SHA-256 hashing, blockchain anchoring, and semantic similarity analysis. Third, we implemented an AI-driven document processing pipeline capable of classification, semantic retrieval, duplicate detection, and metadata generation. Finally, the framework is practical for deployment because it uses Hyperledger Fabric, which avoids transaction or gas fees, and can integrate with existing police and judicial information systems. Thank you. We are open to any questions.
Okay, Nisha ma'am, any questions?
What are the computational requirement of your system?
Okay, so what we need, a basic, um, a computer with good enough NVIDIA, like GPU should be enough, with physical components having a scanner and a camera should be enough for this.
What about the storage, the memory requirement?
For storage and memory requirement, the storage can be done on MongoDB, where you can store your metadata, and all the file structures, all the evidence will be stored on IPFS, for which hash will be generated, and it will be stored on blockchain.
Have you done any cost estimation?
Yeah, so our cost estimation came up to 70 to 80,000. To be honest, it is like based on the scalability. So how much we use, that much it'll be costing.
Okay, thank you.
Yeah, thank you.
Okay, thank you so much for your presentation. So next we have Nisha Verma. Nisha, are you present in the session?
Yes, ma'am, I'm present.
Yes, so she is here to speak on the topic smart footwear to care for old age people. So Nisha, you can start sharing your screen.
Yes, ma'am.
Yes.
My screen is visible.
Yes.
Good morning, everyone. My topic is smart footwear to care for old age people. This presentation focuses on how smart footwear improves elderly health, safety, and mobility. Introduction. Feet support body movement, aging, weakness, muscles, and balance diseases increases foot problems. Smart footwear provides comfort and safety, and its overall improves quality of life. Needs for smart footwear. Prevents slips and falls, improve walking balance, reduces foot pressure, help patients with chronic diseases, support independent living. Features of smart footwear. Detect falls instantly, track location using GPS, monitors health parameters, memory foam, increases comfort, waterproof and electricity safe. Sensor used IMU sensors, measures body movement, accelerometer detects motion, gyroscope checks balance, pressure sensor measure foot force, temperature and ultrasonic sensor monitor health and surroundings. Gait monitoring detects abnormal walking, measure speed and step length, identify mobile disorders, predicts fall risk. support realization, health monitoring. Monitors heart rate and blood pressure, tracks foot pressure, detect diabetic foot ulcers early, sends data via Bluetooth, alerts caregivers in emergencies. Care for special conditions, support dementia patient, helps diabetic patients, assists neurological disorders, improve blood circulation, reduces disorders and falls. Smart materials and biomechanics uses eco-friendly materials fit according to foot shape, increasing flexibility and durability, generates energy for sensors, improve walking efficiency. Now I will talk about methodology. Design footwear based on user needs, integrate sensor and IoTs, collect and data, analyze data, generate emergency alerts, evaluate performance, and improve the system. These are the advantages: reduces falls, improve health monitoring, increases confidence, lowers medical costs, support independent living. Challenges and future scope: manufacturing cost is high, battery life is limited, health data is needs security, AI and sensor will improve, future footwear will be lighter and more sustainable. Conclusion: smart footwear is an important innovation. It combines healthcare with technology, provides safety and continuously monitoring, improves elderly quality of life. Future research will make it more affordable and effective. Thank you for your attention.
Okay, thank you so much, Nisha. Nisha, ma'am, do you have any questions?
What sensors or the technology are integrated into the smart footwear?
Ma'am, some people have a diabetic issue that and as well as BP issue, so that's why I'm using FSR, force resistance sensor. It can detect your pressure in the foot, which can help your future problems.
How
In
it
health.
is improving the safety of the user?
What, ma'am? Can you please repeat?
How it will improve the safety of the user?
How it can be?
Improve safety of the user.
Ma'am, some in our elder, some people are fall because of some health issues. So if in I will adjust some sensor in a footwear, so it can be integrated already. This is the problem.
Okay, I think
I
she
will
has
take.
got her answer. So let's move on with the next presentation.
Thank you,
Thank you
ma'am.
so much, Nisha. Yes. So for today's last presentation, we have Ananda Krishnan P. Are you present in the session? Or any of his co-authors is present in the session? Uh, you're not audible, Ananda Krishnan. You have unmuted, but you're not audible. Hello, are you able to hear me, Ananda Krishnan? Okay, we'll wait for 2 minutes. No, Ananda Krishnan, you're not audible. You can rejoin and check once, or else we will conclude with the session. Okay, till then I will give a last call to the presenters who were absent. No, this was done, right? Yes.
Prashant was there.
Yes.
He was absent.
Everybody was present. Yes, Prashant was absent. So Prashant, or any of his co-authors are present on behalf of him. This is the last call for them as we are about to conclude the session.
So Yashita, Manali Bhosle is with us. She was going to present yesterday, but somehow he was not able to present that her paper. So she want to present her paper right now. So please allow her to present her paper.
Sure. So,
Manali Bhosle.
yes, Manali Bhosle, are you ready with the presentation? So we can
Yes,
take
ma'am.
your present. Yes, so you
Please
can
ask her.
present.
Please ask her the paper number.
Second,
Number
second.
and title. Okay,
Paper.
got it.
mm,
Ma'am, is my screen visible?
the screen is shared, but the presentation is not visible. So when you click on the share button, you'll have
Mhm.
to click on the presentation window and not the entire screen. The green share button, click on that and then click on the presentation screen.
Is it visible now?
No, only the screen is shared and the meeting is visible.
So
Sorry,
Manali,
just
one
give me a
question.
minute.
Hemlata Gaikwad is your co-author, or she will going to present the paper. Can you
Yes,
just
yes, sir.
clarify us?
I'm her co-author.
Okay, got it. So you are presenting on her behalf.
Her behalf. Yes, yes,
Okay,
yes.
got it.
Is click on the green share button now and then click on the presentation window.
Ma'am, I've already shared.
But the meeting is visible, the presentation is not visible. You'll have to
Still the
click
meeting.
on.
Still the meeting is visible.
Yes,
Please click on the presentation window
window.
so that we can see your window, so that we can see your presentation. You can guide Yashika.
Yes. So right now, the meeting is visible, so you have to stop the sharing
Okay.
and then on the screen you have the share button. Click on the share button. Then you'll get
Yes.
all the tabs which are open, right? So the tab which on which your presentation is there, you have to click on that tab and then click on share.
So all you have to open a presentation, then it will shown in the share button. So that is also a thing. You can check
Yes.
and just let us know.
First
Yes, I've
open the
already.
presentation.
In Windows, I can just see single screen in Windows. I can just see that
Mm.
single screen.
Mm, Here
Mm.
now it is visible. No, it is not. Wait.
Still not?
No, no, no.
No, you
Just
can
give
do
me
one
a
thing.
minute.
Yes, you can
You can
share
do
the
one thing.
presentation with me.
Yes.
Mm.
Where shall I share now?
I'll share my mail ID.
Please check your
Yes,
chat box.
yes.
Mm.
Yes, yes, Ral.
Share your presentation on this mail ID. I will share the screen. After Manali, Anand Krishnan, you have to resolve your issue. We will be taking your presentation after this one. If it is possible for you to speak. Have you shared the presentation?
Yes, 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 ma'am. Yes. Just give me a minute. Will you please check, ma'am? I've shared.
Yes, I'm checking with them.
Yes, ma'am.
Yes, okay, there. I will share it 1 second. Okay, I'll share now. You just have to tell me when do I have to change the slides, okay?
Yes, sure.
Yes. Yes, you can start, Manali.
Yes. So good morning. I am Manali Prakash Bhosle on behalf of Dr. Hemlata Gaikwad ma'am. I'll be presenting our topic, a review on managing workplace stress in Generation Z employees. Next slide, please. So workplace stress is becoming one of the biggest challenge for young employees in this for young employees. So in this presentation, I'll be explaining how AI can help can help the organization to provide personalized mental health support for Generation Z employees. So this study will explore how AI technologies like chatbots, wearable devices, and personalized wellness applications can reduce workplace stress and improve employee well-being. So coming to the abstract, this paper is a systematic literature review. We reviewed previous studies on AI assisted well-being interventions, so which includes AI chatbots, wearable devices, emotion recognition systems, and digital cognitive behavioral therapy. So our review found that these technologies can reduce stress and improve employee well-being. However, there is still very limited research specifically focusing on Gen Z employees in workplace. So therefore, we propose a conceptual framework that connects AI personalization, employee engagement, stress reduction, and organizational productivity. Next slide, please. So Gen Zs are different from previous generations. They are digitally natives, highly connected through technology, and they expect quick communication and personalized support. So, however, they also experience high level of stress, anxiety, uncertainty, and work burnout. So traditional employee assistance programs are often not attractive for them, as they expect immediate and techno based solutions. So Gen Z usually prefer instant support, flexibility, and personalized experiences. AI has potential to provide exactly the same whatever they need. Next slide, please. So this slide explains why AI is becoming more important to employee well-being. Since Gen Zs are already uses smartphones, applications, and various devices. So organization can use AI to provide continuous, personalized mental health support to them, which can help to reduce their stress and um, which will help organization to improve their productivity. So AI can monitor the stress patterns, provide timely recommendations, and improve the access to well-being resources. Next slide, please. So AI-based well-being interventions, which we studied, were AI chatbots. AI chatbots provide immediate emotional support. They answer quick questions and guide the employees. Then wearable devices, they monitor heart rate, sleep quality, and which identifies the stress indicators. Then we had emotional recognition. AI can identify emotional change through facial expression, behavioral pattern, through speech. Then we have digital CBT, digital cognitive behavioral therapy, which delivers evidence-based mental health exercise through the application. Then continuous monitoring. Organization can monitor overall well-being trends using anonymous and aggregate data instead of waiting until until the stress reduces. Uh, Next slide, please. Yes. So our review identified several important findings where AI chatbots improve access to mental health support. Variables provide objective to get the psychological information of the employee of Gen Zs specifically. So, however, more studies were conducted on students or general population rather than specifically focusing on Gen Zs who are working in the organization. Next slide, please. Uh, so the slide summarizes that difference between existing research and future research needs. So although AI-based well-being technologies have shown promising result, but very few studies evaluate the effectiveness among Gen Z employees in the actual workplace environments. So this is the opportunity. This creates an opportunity for further empirical research. Next slide, please. So our study has four main objectives, which focuses on reviewing the AI assistant stress management interventions, then to examine whether personalized AI approaches are suitable for Gen Z, then to identify the outcomes, and then to develop a conceptual framework. Next slide. So the scope of the study includes Gen Z. The review covered AI chatbots, wearable devices, emotional recognition system, and digital wellness applications. So the main outcome considered uh, in which included reduction of stress reduction, employee engagement, well-being, and productivity. Next slide, please. Yes, so coming to the last slide, uh, our conceptual framework explains how personalized AI intervention increase employee engagement. Higher engagement leads to lower workplace stress. It can reduce, it can improve stress and employee well-being, which ultimately enhances organization productivity. So, in conclusion, AI should not replace human support but complement existing employee well-being programs. So organizations should implement ethical, personalized, and uh, personalized AI solution for Gen Zs. So thank you. I welcome the questions.
Why this study is especially designed and developed for the Gen Zs only?
Yes, ma'am. Because the previous generation, they were aware of stress management and aware of work-life balance. But coming to the generation Z, Gen Z has very less adaptive or they have very less patience. So this study specifically is designed for generation Z because stress level in Gen Zs is very high comparatively to the previous generations.
Okay, thank you.
Yes, thank you, ma'am. Thank you so much.
Thank you so much, Manali, for your presentation. So,
Thank you.
Anand Krishnan, are you ready with the glitch solved?
Yashita, how many presentations are remaining now?
One.
Okay.
Yes, ma'am. Anand Krishnan, are you ready? Okay, I think there is some glitch, Anand Krishnan. So we will let you know that when you can present in the next session. So till then, we will conclude the session.
Hello.
Ma'am, can I present
Oh.
my paper ID 135?
Hello.
Hello, is
Yes,
Anandashna is
Amrita.
presenting. Okay? I am part of Anandashna's team, so we will be presenting now. I'm audible.
Yes, you're audible. Okay, fine. So on behalf of Anand
Okay, I'm
Krishnan,
sorry
you are
for the
going to
delay.
present, right?
Yes, I'm going to present. I'm sorry for the delay, actually. Really
Okay.
sorry.
Yes, you can start. Just take care of
I
the
hope
time.
the screen is. I hope the screen is visible.
Yes.
Okay, so good morning, everyone. So we will be presenting the topic like the greenwashing, like impact of greenwashing on consumer trust and purchase intention in India's online skincare market. So it's our studies actually examines how the greenwashing, like the misleading the environmental claims made by the companies that actually affects consumer trust and the purchase intention in the India's online skincare market. So we also get whether this transparency tools like the digital product passport can also rebuild consumer trust. So talking about the research background, the demand for the eco-friendly skincare products actually increased because the consumers are really becoming more environmentally conscious. However, actually, like many companies make exaggerate or like false sustainability claims, a practice known just like a greenwashing. This is making it like difficult for the consumer.
Amrita, your voice is not audible. Amrita, are you present? Are you able to hear me, Amrita?
think we should move
So,
on
Hello,
to the next.
yes.
Okay. She is.
Okay, she is
I'm
present.
sorry. Hello,
Yes,
hello.
Amrita. Yes.
Can I see the
Amrita, please be in the
presentation?
good
You can see
network.
the presentation. Okay, I'm
Uh,
sorry for that.
you can
I hope the
check your
presentation.
network connection and be in a good network connection, please.
Okay, I think you can see the presentation now, the
Y
research background.
yes.
Okay, actually, the demand for eco-friendly products, skincare products, actually, we can say that increased consumers becoming more environmentally conscious. Like companies make exaggerated or like false sustainability claims that practice we commonly known as greenwashing. So this makes it actually difficult for the consumer to identify whether genuinely these sustainable products and reduces their stress. Understanding these issues in the Indian's online skincare market. So coming to the research questions, our study addresses two main questions. That is, how does the digital product passport influence the consumer trust when buying the skincare products online? So, and the second one is that the how do the ethical claim labels the affect the consumer trust and purchase intentions? So, I feel like these questions helps us to understand whether the transparency can reduce the negative effects of the greenwashing. So, coming to the literature review. Hello.
Yes, Amrita.
Hello. Okay, and this is a literature review. That slide.
No, it is still on the research background slide.
Okay. And this now, I think you can skip to the literature review back.
Yes.
Okay, literature review, we see that greenwashing actually decreases the consumer trust and the purchase behavior. And many false sustainability claims actually increases the consumer skepticism, and the digital product passports enhances the transparency and the product verification. So the research gap actually we find here is that the limited studies are there in the Indian online skincare market and the digital product passport. Next. Research methodology. Next. And Dishna, next slide. Hello, and Dishna, I'm audible. So, okay,
Have you
the
done
research.
the presentation?
No, I mean, talking about the research methodology, how we have taken the how we had done the methodology is like we adopted
Just
like a
a fast
descriptive and
visual
exploratory.
presentation.
I'm sorry. Hello. Hello.
Ma'am, what you can do is just summarize the rest of the part.
Okay. We just adopted a descriptive and exploratory research design, like a primary data way collected by the 100 online skincare consumers, which was a little bit a convincing sampling, and the data collected through a structured questionnaire. So the key variables that we used here is independent variables include like information quality, green symbols, digital product passport, and the social proof, and the cruelty-free and vegan attributes. So in the regression model, the regression analysis showed that the model explains like 37.1 percentage of the variation, and the green symbols beta is equal to 0.418, and the digital product password like 0.275. And the key findings of our paper is like the green symbols and the eco-friendly labels significantly actually increase the consumer trust. So this improves the trust by providing a transparent and verifiable product information. So the information quality alone is not enough unless the claims are just been verified. So social proof, brand reputation, perceived risk, and the cruelty-free or vegan claims were not justly satisfactorily significant. And coming to the conclusion, I see like greenwashing negatively affects the consumer trust in India's online skincare market. And the green symbols and the digital product passports are the strongest drivers of the trust. So, for I feel like therefore the company should focus on transparency and the verified sustainability claims and digital product passports instead of like relying on the misleading environmental marketing. So this will actually build a long-term consumer trust and improve the purchase intention. Thank you. Hello.
Okay, thank you so much, Amrita.
Ma'am, next, can I present my
Okay.
paper? Paper ID is 135.
Yes, you'll have to wait. Nisha ma'am, do you have any questions? Okay, I think there are no questions from Nisha ma'am. So Prashant, you can start and just
Thank you. Thank you so much, ma'am.
yes, you'll have to take care of the time.
Yes,
Just
ma'am, I will be winding up within 2 or 3 minutes. So basically, this is our paper ID 135. Good morning to all of you. My paper topic is AI-driven credit worthiness assessment and credential verification and corporate lending system. So basically, the object was to develop an intelligent AI-based system for your credit worthiness assessment and credential verification in corporate lending. So basically, the proposed work evaluates both the financial and non-financial data, including your financial statements, transaction history, repayment behavior, corporate governance indicators. So using machine learning and ensemble algorithms. So basically, we are working with accurate credit risk production. So it integrates your automated credential verification to authenticate your borrower information and reduce your fraud. It also employs your explainable AI for transparent and trustworthy lending decisions. So basically, companies they require accurate and reliable credit worthiness assessment to minimize their financial risk. Limited financial indicators, manual verification, and rule-based process they basically leads to delays and inconsistencies with your potential biases with the traditional credit evaluation. So rapid growth of AI and machine learning has enhanced the credit worthiness assessment and credential verification. With the financial institution, they can enhance their decision making, reduce their default rates. So basically, we have proposed an AI-driven framework that combines both the machine learning techniques with automated verification to improve the efficiency, transparency, and security. So this was the related work where we have seen that AIML has significantly improved the credit risk protection prediction with the loan approval decisions with gradient boosting, deep learning, and transformer-based architectures. They basically helps to capture the borrower behavior over time. So this improves your fraud detection, default prediction, and financial decision making. Also, with limited interpretability with your complex AI models, traditional system they rely heavily on your financial record. So real-time credit credential verification is often missing with the existing frameworks. So this was the motivation for the proposed work to develop an AI-driven corporate lending framework to integrate your credit worthiness with improving your accuracy, transparency, and security. So this was the framework that we have proposed. It is basically a three-tier architecture which works on the multi-dimensional data inputs. Then AI/ML modeling framework is there where the high accuracy, low predictive rate, default risk, scalability, and the model explainability has been taken care. And with the automated data authentication, AI-powered decision output has been provided to take with the to help the companies to make their decisions. So further, if you will see the benefits of this is that performance, we have achieved higher credit risk prediction accuracy. We have successfully identified the low risk and high risk borrowers with improved classification performance, reduced false positive and negatives. We have also enabled the real-time credit assessment. It also brings the transparency and interpretability of model predictions. So the key outcomes were that business outcomes, if you'll be talk about improved loan approval quality, reduced default rates, then enhanced fraud prevention, faster decision making. Technical outcomes is that high predictive performance has been attained. Transparency decision support has been attained through explainable AI. So basically, in our proposed work, we can say that the AI-driven credit worthiness assessment and this credential verification delivers more accurate, transparent, secure, and efficient corporate lending system, which enables the financial institution to basically minimize your risk, reduce fraud, and accelerate your loan approval while improving overall operational efficiency. With this, I would like to end my presentation. Any questions if you have? Thank you.
Okay, Nisha ma'am, any questions?
What are the practical applications of your system?
Ma'am, basically it helps the corporate lending systems to basically check the you can say profiles of their lenders that to whom they are lending the money and all that. So basically, all traditional systems they are not capable of you can say doing the verification thoroughly, and also sometimes biases are been done.
Have you done
So
any deployment cost estimation?
Ma'am, this is to be under process right now. This model is to be still tested for the real time data.
Okay, thank you.
Thank you, ma'am.
Okay, so this was the last presentation for today. Thank you so much, Prasant, for presenting. And
Thank
we
you.
have come to the end of this session. So I sincerely thank all our authors for their excellent presentations and valuable contributions, and all the participants for being an important part of this international conference. I truly hope that this session was insightful and engaging for everyone. So, on behalf of the entire team, we thank you for your continued support, not just for this edition but for all the previous editions of ICT4SD. We look forward to welcoming you again in the next version in 2027 as well. So all presenters will receive their digital certificates via emails within 2 working days, and the publication will be live within 7 to 8 months. So we kindly request your cooperation with the ICT4SD 2026 team. I would also like to extend my sincere thanks to our session chair for expertly chairing this session. And this is a small token of appreciation on behalf of Team ICT4SD and Global Knowledge Research Foundation and partners. So, thank you, Nisha ma'am, for joining us as session chair. And thank you all once again for your presence. And before we officially wrap up, I think we should capture this as a memory. So, I kindly request everyone to switch on your cameras so that I can click a quick snapshot of this conference. Okay, 1 second. I'll click quickly. Okay. Thank you so much, everyone. Stay safe. Take care. Thank you, everyone, for joining.
Thank you.
Thank you, ma'am.